Okay, so question 1D, this is the equation of the line that we just calculated in the previous part. And that's the equation of the line that goes through A and B. In D, it's a 3-mark question. Find the area enclosed between the straight line and the curve. So I would like to get the right answer, and I'd like to write a definite integral that represents those values. I know that that goes through at -1, and that goes through at 1, and that's at 0. So I'm going to write a definite integral. I'm going to call this y1. So the area is going to be the definite integral from -1 to 0. So I'm doing this bit first. And it will be top curve, and the top curve is my cubic, and my cubic is called f of x. So it's going to be f of x minus y1 dx plus the integral from 0 to 1. And in this particular interval, from 0 to 1, the y curve is the top curve minus f of x dx. And that's going to give me my method mark. And then I can just write the answer. And I can use my calculator to do that. So a couple of ways. I can do the integral from -1 to 0 of top curve, which is this, copy, paste, minus, and I'm going to put in a bracket. I'm going to put the equation of the bottom curve without the y, dx, and that's going to give me that answer, which is 1/4. Plus, and I bet you the other one is 1/4 as well. So if I take this down, and I'm now going to go from 0 to 1, and of my cubic, I'm going to select the cubic, put a bracket around it, and put a negative out the front, and turn that one to positive. And that gave me positive 1/4. And that's going to give me a half square units is going to be my answer. A nice 3-mark question. Could I have done that down here? Yeah, well, yes, I could. I could have taken my straight line, and if I just zoom around the area, and if I go analysis, G-sol integral intersection, I'm going to accept the first one. I'm going to come to the third one, and it gave me the areas to be a half. Perfectly okay as well. However, I did need the integrals to get the full 3 marks. Okay, part E. The value of k for which f of x and g of x for all x. Okay, so f of x is x cubed minus 3x plus 2. I want them to be equal to each other. So if I take that and put that in a new line, equals x cubed bracket, plus bracket, I'll use y instead of k. Advanced solve for k, but I used y instead of k. K equals 1. 1 mark answer, and there it is. And of course, if that has to be a 2, then k has to be 1. And if that has to be a 3, -3, because I want a -3, k has to be 1. Find all solutions for the derivative of g equaling 0. So this is my derivative of g, this expression here. So if I take its derivative, and I make that equal 0, and I solve for x. So that's going to give me 2 answers. X is going to equal negative square root of minus 3 k minus 4 on 3. or positive square root of minus 3k minus 4 on 3. You could have, if you wanted to, written that or other variations of it. So they're my two answers for F. Find the value of k for which g has only one stationary point. Well, this is about stationary points. So it's telling me there are two stationary points. Now, the value of k where this is equal to this means I'll have one stationary point. So if I make my two answers down here, these two answers, I grab that keyboard, copy into a new line, paste, equals the same thing but with the... So just to I will have only one answer if both of these give me the same value, because then it wouldn't be two separate solutions, it'd just be the one. So if I set that equal to each other and go solve for y, and that is k equals 4. One result, and of course when k equals 4 that's 0, which means the answer is 0, and when k equals 4 that's 0, which means the answer is 0. And lastly, the values of k for which g has 3 x-intercepts. So g is this thing here. We're not talking about stationary points here, we're talking about intersection points. So if I do g of x equal to 0 and solve for x, that will give me the x-intercept. So where is my g of x? Here is my g of x. Copy, come down, paste. I don't need to make it equal to 0. So I get x equals -2, x equals the negative square root of 1 minus k plus 1, and x equals the positive square root of 1 minus k plus 1. So that gave me 3 solutions. So there are my 3 intercepts. Now, the values of k where that actually exists is where 1 minus k is bigger than 0 or equal to, because you can't have a negative square root. So that is negative k bigger than or equal to -1, k is less than or equal to 1. Now I can't make it equal to 1, because if it's equal to 1, both of these will be the same value, and I'd only have 2 x-intercepts, the -2 and that 1. So I'm wanting k less than 1. Now that's all very well and good, except some of these values of k will make this give me the same as -2. Therefore, I'll have a double up and I'll only have 2 x-intercepts, not 1. So if I take this one and make it equal -2, solve for k, that will tell me the value of k that have them equal to each other. And that's -8. So when negative the square root of 1 minus k plus 1 equals -2, k equals -8, which means this one and this one will be the same, which means I'll only have 1 x-intercept from those two. That will give me 2, so that's not 3. And also test for the other one when the positive equals that, and this is not possible. So my only exclusion is -8. So k is less than or equal to -1 except for -8. Or you could say that k is an element of -infinity to -8 union -8 to 1. Either of them will exclude the -8.